So how's your week going, everyone? As Jenna said, happy Wednesday. Here we are midweek already. It's going pretty well, Jenna. It seems odd that it's already Wednesday. Everything seems to be just kind of flying by quickly. All right, I want to show you guys something on the calculator today. So I'm trying to set that up. I might need to adjust the height of my tripod a little bit. But other than that, I should be okay. And I might be able to show it to you a slightly different way too. I have my other computer, I might just do that. So just a quick question for those of you who are here. It's just 5 of you, but that's okay. Who has a TI-84 or TI-83 or other TI calculator? If you do, just say I do or yes in the chat so I know who I'm talking to on this. So we got Zach, Jenna, Megan. Mateo, what about you? Okay, so Dayton, you're using a non-graphing calculator, and that's okay. That just means that what I'm going to show you today, you'll do in Desmos. So what I'm going to show you guys today, you can do in both Desmos and on the graphing calculators. And it's sort of, it's just as easy to do in one place as the other. It's going to be kind of personal preference. So everybody can do this in Desmos. The cat is trying to break into the room. And what about you, Mateo? Do you have a graphing calculator or no? Not going to tell me. All right, so that way I know at least we're going to do both ways. I'll show you how to do this. Okay, Mateo, you know, for this class, it's actually okay. I think you'll do fine with just using Desmos. So if your sister has one that you want to borrow, it might be easier for a couple of things, but otherwise, use Desmos along the way. You'll be just fine. I wouldn't go out and buy one. You can also rent one from Delta, and they aren't charging this semester for the rentals. They're just having you check them out through the library. So you can contact the library if you want to try to check one out. That is an option. And if anybody needs help navigating that, just give me a holler. Okay, thanks, Mateo. All right, do you guys have any questions before I hit the calculator stuff? I don't know if you noticed or not, but the textbook sections were going along, and then And then after section 3.6, it shows linear regression Newton section. So that section isn't in our intermediate algebra textbook, but it is in Newton. So it's something we're going to be responsible for, and it's something you're going to need to use on the first project. So the project is going to be sort of calculator, computer based in a way, and that means you're going to have to know how to do something either in Desmos or on the graphing calculator. So we'll have that option. But if you guys have any questions first, I can take care of those, and then we'll do the calculator bit, because sometimes it's not really hard, but if you're not used to doing it, then it's something new, so you need to learn it. Okay, you guys are being quiet today. No questions right now that you can think of? Okay, I think I'm going to do Desmos first because I can do it pretty easily from my computer, and then I'll fiddle around with the camera, and maybe you guys will come up with some questions before that. Did anybody get to that section on linear regression yet? The one that says linear regression, Newton section? Is anybody that far?
No.
Megan's a no. Todd, are you that far yet? Jenna said not yet. Okay, good, because that means you won't get there and get frustrated because you don't know how to do the calculator part of it. All right, so I'm going to just share from, yeah, we'll just share Chrome. And then we'll go to, and remember, you can get to Desmos from both from a browser, but you can also get there from the app. So the apps work pretty nicely, and that should work for you as well. So just a reminder on how Desmos works for graphing, and we'll just do this really quickly. Let's just graph the equation of a line, and I'm going to do something like y equals 2x plus 3. So you guys remember how to do that, right? And that you can like click on the points if you want to. They show you points of interest, which is really kind of nice. Hide that. Okay, so what this section is about is making scatter plots and then coming up with equations of lines that fit them as well as possible. So we know that when we come up with an equation of a line, all of those points fit precisely on that linear representation that has a certain slope and y-intercept. And if I find more points on the line, they fit the equation exactly. So all of the points on this red line satisfy this equation, y equals 2x plus 3. If we plug in the x and the y, they match up perfectly. That's kind of what we mean by the equation of a line. But in reality, if we're working with data, it's probably not going to be all that nice and neat. So what you might have is a table of values where they give you an x value and they give you a y value, and they might not match up in a perfectly linear way. So in Desmos, I'm going to add a table, and notice that they label them x1, y1. And we're just going to put some points in here, and we're going to go 0, let's say 3.2 and 1. 5.3 and 2, 7.1, 3, 8.8, and I know you can't see all of these because we're kind of off screen. We'll do 2 more. We'll go 4, 10.5, and then 5, 13.1. So while I was putting those in, they were getting plotted. And you notice we have the little green dots here. So this is showing up as green dots. And I'm going to set the window a little bit differently so we can see a little bit higher. Let's go -2 to 7 for my x-axis, and let's go -2 to 15 for my y-axis. And then we'll get rid of, oops. Yeah. Okay, we're going to get rid of that. I actually have a Desmos account. I'm just not logged in there right now. So notice that the red line actually fits kind of nicely to some of those points. They don't fit exactly, but it looks like it could be an approximation to the equation that would maybe best fit those points. And so what we're going to look at with linear regression is coming up with the equation of a line of best fit. The algebra behind the calculations that get to this is kind of beyond what we would do in this class. So the good news is we don't have to compute it by hand. If we were going to compute it, you could kind of think of it this way. The idea is to minimize the sum of all these little distances between the point and the line. So we want to find the line where the sum of those distances is as small as possible. And that's called the line of best fit, or a linear regression. So anybody heard of a linear regression before? I don't necessarily expect a yes there. No one's jumping out on that. So I'm guessing none of you have worked with a linear regression before, but we're going to come up with an equation that roughly fits the equation that best matches these 6 points that I came up with. And I'll show you how to do that in Desmos, and I'll show you how to do that in on the graphing calculator on the TI-84. So in Desmos, the first thing you have to do is put in your points. So you would enter your table much like I did here, this x1, y1. The red line doesn't really need to be there, but we're going to leave it there as my just initial first guess. So to make all of the points fit, what we're going to do, notice they use the x1, y1. Those are what we need to do. And does anybody remember one of those equations for a line that we came up with back in our coming up with equations of line section? What did it look like? Y equals, who remembers? The one I'm thinking of is the slope-intercept form. What was it? Sort of the easier one to remember. Y equals what, Jenna? Yeah, thank you. Y equals mx plus b. That's okay. Sometimes you hit enter accidentally. Okay, so we're going to come up with an equation in the form y equals mx plus b. But to do it, the hint back here on the syntax that we're going to need is these little subscripts. So we're going to type y1. We're going to type y1. And notice when I put the 1 in there, it automatically subscripted it for me. So I don't have to do anything fancy to make that a subscript. It's automatic as long as I already have my table in place. And then I'm going to say equals. And I got this little exclamation point because there's something missing. And I'm going to say m. And I'm going to say x1 plus b. And I'm not sure what the heck happened to my equation up there. That is what is wrong with it. Let's see if it'll tell me. X1 and Y1. Oh, yeah. I know what's wrong. So that's okay. We'll leave that there. The problem is my equal sign. So if you do this and you run into the same trouble that I just did, you'll remember that this is not quite right. And the reason it's not quite right is that this isn't an exact matchup. Remember, these points are just approximately linear. So we're going to use a symbol here for approximately equal to. If you're working on your computer keyboard, it's going to be the tilde. So to the left of the 1 and the exclamation point, the shift tilde. And the black line is the linear regression line. And notice that it automatically plotted it, gave us all sorts of information down here. We've got to sort of sift through that a little bit. But M is 1.90857. Remember, on the red line, I had the slope of 2. And B is 3.22857. I had a B value of 3. So my initial line was actually pretty close. And I'm going to turn that one off for a minute. That black line is what we would call the line of best fit. Now, all you really need in the information about the linear regression are the parameters, the M and the B, because that tells you the equation of the line. If you're doing a problem in Alta, just make sure that you round those to whatever accuracy they want. So if they wanted 3 decimal places, you would type y equals 1.909 x plus 3.229. So you would round each of those values to 3 places after the decimal. These values up above, I'm going to do the residuals first. I'm going to plot them. You'll be able to see what they are. The residuals are the difference between where you were on the graph of the line and where the point was. So on the line, it's 0, 3.229. The point was 0, 3.2. And notice when I said plot them, they got added to the table. So the E values are just the differences in the Y value on the curve and the Y value from the table. And notice that those are all pretty small, which means this is a pretty tight fit. This fits pretty well. This R value and R squared value is a measure of how closely you fit. If your R and R squared values are close to 1, then this is a really good fit. Notice my values are over 0.99. This is almost unheard of in real data. So if I were working with data from a real situation, an R value of 0.9954 or 9977 would be unheard of. Oftentimes they use R squared because it's always positive. If the slope of your line is negative, this R value is going to be negative. So they just considered the R squared value in that case. But it should be close to 1. If it's close to 0, then this is a really bad fit, a poor linear fit. And then in between, it just kind of goes up and down. So what I'm going to do is I'm going to put a table of values into Desmos, and I'm going to ask you to see if you've got Desmos, if you can come up with this best fit line. And I'm going to even do a few less than we had there. So we'll just insert a table, and notice they switched us to X2 and Y2. We're going to start with 2, 5, and we're going to leave the decimals out. 3, 3, 4, 1, and 5, 0. So those 4 points. So what I would like you guys to do is see if you can get into Desmos. You can do this on a phone, on a tablet, on your computer, whichever thing you're using, and see if you can come up with the equation of the line of best fit. notice that these points are going downhill, so we should have something with a negative slope. And you'll do it just the same way as before, but instead of using y1 and x1, you need to use y2 and x2. I was just double checking to make sure I had the recording on, and I do, so we should be good for anybody who missed class today. Myself over there. While you guys do that, I'm going to fiddle around with my camera and try to lower my tripod a little bit so I can show my calculator for those of you who want to use the TIs on this. Okay, so if anybody has an equation for this, let's type it into the chat and round M and B to 2 places after the decimal. Actually, it looks like we can round to one place after the decimal because everything is just given that way. Did anybody come up with that same thing that I got? Yes, no, did you try it? Jenna, did you get that to work? Who said they've been using Desmos? Mateo, Dayton. Oh, okay, she didn't try. Yeah, that's why I just said who's got Desmos. Did anybody try that in Desmos? Okay, then let me ask this a little bit different way. Does this seem like it's pretty straightforward and easy to do as long as you can input your data correctly? Honestly, the biggest mistakes here are probably just like maybe, entering a number wrong. Notice the R value on this one is negative 0.9898. So we have sort of a negative correlation as the X values increase. Okay, thanks, Mateo. I'm glad we agreed. And the R squared value, of course, is positive. Also notice those are close to 1 and -1. So that means we have a really good linear fit. If the points are just scattered all over the place, then those R values will be smaller. They'll be closer to 0, the R and the R squared. And I'm going to take that first one out of there because we're going to use the second one again. First one out of there so that we only have the one graph to show. We're going to kind of compare this to the calculator. And I think I have this going, although I'm not really sure what my phone seems to be doing. So we'll see how that works. If worse comes to worse, I will hold the calculator up and you guys can just take a peek at it. Oh, that's not going to be good. So there. And what I can't figure out is why. Let's stop that share. All right, that is not behaving for me. So I think what I'm going to do is we're going to do this a little bit differently. And I will just share, I think I can share from here. And okay, so you guys got that? No. All right. Who can see my calculator screen right now?
I can.
Okay. But I can't. Let me see if I can pin that for myself. You can still see it?
Yes.
Okay. This is so bizarre. Oh, now I can. Okay. All right, we're gonna kill video here. You still got it?
No.
Okay. I just was trying to, these devices are really close to each other, and I was trying to double check which one you were seeing it from. So can you see it now?
Yes.
Okay. All right. Okay, so what we're going to do on your calculator, so you guys have your handy dandy TI, and the place that we need to go is to where we're going to enter information. And I will post a handout up in e-learning that shows you the steps on how to do this, so that you have like a written out list of steps that you can go back to later on. It's not there yet, but I will make sure that I post that. Okay, so the first thing you're going to do, I'm going to have to peek at my calculator to remember the name, is you're going to go to the stat menu. So it's the second row down and the third button over from the left. It says stat. And when you press that, you should get a screen that looks like that. And once you have that, the first thing we're going to do is edit, because we're going to need to enter our data. So we're going to hit enter on that edit screen. And then you're going to get something like this. Now, I had data in here from something I did way back when, so I'm going to have to get rid of that. If you've never used this area of your calculator, you're probably just seeing a bunch of empty lists. And there are 6 of them there, list 1 through list 6. So if you do have something in there that you want to get rid of, what you're going to do is you're going to use your up arrow to go to the list name and then hit clear. So up arrow, that up arrow key, and notice how L2 is now highlighted. And then this is really hard because I'm working backwards, clear, and enter, other side of the calculator. Again, working with a mirror image. And then I'll do the same thing with list 1 so that it's cleared, and I'm just starting with a fresh slate like that. And then what we're going to do is we're going to put our X's in our list 1 and our Y's in our list 2. And we're just going to hit enter between each of them. So X's list 1, Y's list 2, and I need to take myself on my computer back to Desmos so I can see what those were. So my X's were 2, 3, 4, 5. And my Y's were 5, 3, 1, 0. And once I enter those, they should look like that. Yeah, Megan, this is kind of weird. It's a lot of punching. So if let's see if you can get to, did you get to the stat menu, Megan?
No.
Okay, so let's get you into the stat menu. You got your calculator out?
Yes.
Okay, so take a look at your calculator. Do you see that key that says alpha? It's probably green.
Yes.
Okay, now go 2 to the right of that.
Oh.
There should be a key that says stat.
Mm-hmm.
So press that.
Yes.
Okay, now when you press that, I'm going to get myself back there. Across the top, it says edit, calc, and tests.
Yeah.
And then down, the edit is highlighted, and the first thing that's highlighted is edit.
Mm-hmm.
You're going to press that. Press enter.
Gotcha.
And then when you press enter, those lists will come up. My numbers are already entered because I just put them in there.
Mine's weird. I don't know if you can see it.
Okay. Yeah, so you have a newer calculator than me, so you can see a little bit more on your screen than I do, which is nice.
Mm-hmm.
You can see more of the lists, but you're only going to use 2 lists at a time.
Okay.
So if you go down in your list 1,
Mm-hmm.
you go 2, 3, 4, 5. And then in your list 2, you're going to do the 5, 3, 1, 0. So your calculator won't look exactly like mine, just because you have better screen resolution and you can see more of your list, but it should essentially be that.
Oh, okay. Oh.
Okay, so
Are you all
Megan,
right? It's a lot of punching stuff in.
so Megan, are you with us?
Yes.
And Jenna is with us? I can't, oh, Megan said she was, okay. And Jenna, you're good?
Yeah, I'm all good.
And who, it was Dayton? No, it was Zach. Zach, are you good? Okay, thanks, Zach. Okay, so now we've got this info in our calculator and we just need to get out of this part of the calculator, essentially get out of this program. So we're gonna quit it. And to do that, quit is on the mode key. So you're gonna hit second and then quit. So second quit on your calculator, and that should just take you back to your home screen, to whatever you were doing before we were working on trigonometry here. So that's why there's some tangent stuff on here. You have whatever calculations you did on the home screen last. And if you don't like those, you can just hit clear and get rid of them. And then you're back to just a blank screen. And I promise, in fact, I will send it to you. I can send it to everybody today in the chat as well, so you don't have to go search for it. And then I'll just go post it for everybody else who wasn't here today, the instructions. Okay, so next step, we're going to go back to stat again. So you're coming back to this screen. But this time we're going to calculate the linear regression equation. So we're just going to shift ourselves over to where it says calc or calculate. And we just do that with the arrow keys. So these four arrow keys, you're just going to use the right arrow to move over to calc. And that puts you right there. So give me a yeah, I'm there when you're there, either in chat or verbally.
I'm there.
I'm there.
Okay. So Megan and Jenna and Zach, are you guys all there? Got it. Thank you. Okay, so now the thing we want to calculate is a linear regression. So do you see it in the list? Number 4, linear regression. And you can get there a couple of ways. You can just use your arrow key and arrow down to it and then hit enter, or you can just type the number. So if we notice that it's number 4, if we just type a number 4, it will automatically take us there. And it typed in linear regression AX plus B. So they're calling the slope A instead of M. But other than that, it's the same thing. And if we hit enter, it's going to give us the equation of the line. And we got A equals negative 1.7, B equals 8.2, and that looks familiar. That looks like what we got in Desmos. Notice that my calculator did not show us those residuals, those R values. There's a little thing that you can toggle on and off on your calculator to show those if you're interested in them. They really aren't necessary for us. We're not going to get that deep into the data explorations that we really need them. So if they show up, it's fine, but if they don't show up, it's also fine. Did you get it to work, guys?
Yep.
Megan, Jenna, Zach, give me a thumbs up or a something if it
Yep,
worked.
I'm all good.
Okay.
Yeah, I'm good. It
So
took me a second.
this takes some practicing, some getting used to. But let's try one more. So this time we're going to try to come up with an equation of a line. I'm going to give everybody like 4 points again. I'm going to go back and type them in Desmos, and you can do this either place. So you can either do this in Desmos or on the calculator. It's totally up to you. But I'm going to type them in Desmos and share my screen so everybody can see the same table. And I know I'm not sharing screen yet. I'm just going to plop these in here first. Okay, so you guys should be able to see my screen share. And notice that I gave you 5 points, and they aren't really that great in terms of a linear relationship this time. Did you guys see that? See how they went up and then came back down? That doesn't mean we can't come up with a line of best fit. It just means it might not fit as well. So go ahead and use those 5 points, either using Desmos or your TI calculator, and see if you can come up with the linear regression. Oh, for the calculator users, remember you'll have to go up and clear that entry. So you'll want to clear list 1 and list 2 so that you can type the new 5 points in there. Okay, and when you get this, go ahead and type into chat whatever equation you came up with. We'll all be brave. We'll see if we agree. Okay, so I just dropped a file in the chat. It's a Word document. So I think everybody should be able to open it, even if you have just something to read it with. You should be okay. And that has the instructions for setting up that scatter plot. It even has a little bit more. Okay, 1.1x plus 3.6. That's what I got rounded as well, Jenna. And if I go back here and do it this way, y1 is approximately mx1 plus b. So there we have it in Desmos now. All right, that's good because that means Desmos and the calculator agreed because Jenna was using the calculator and I think Mateo was using Desmos. And then I used Desmos here. But that handout should help you out with the calculator version of this. Notice the handout also has some other info. Just a quick note. So I'm going to switch my screen share to that document. Word. There we go. And so here's the document that I just shared with you. If you weren't able to open it yet, this is what the document looks like. So the first part A tells you how to enter the data. And then part B says how to set up a scatter plot. Now we didn't really play around with that. I just went ahead and plotted. I didn't even plot the points. I just came up with the equation. So if you wanted to just plot the points, you're going to go into stat plot so that you can see the points plotted. And I usually use plot 1 and then turn it on. So I'll show you that on the calculator next. And then we're going to choose the type by highlighting the icon, the first icon. And then we're going to plot the data and find the equation. So let's stop that share. And so there's what your calculator looked like after, weird lighting. That's a little, there, that's better. After you came up with the calculation, but some other things that you could have done. So on my y equals menu where you usually enter equations, I'm just going to make sure that that's all cleared out. And then above that, you see where it says plot 1, plot 2, plot 3. We're going to move up to plot 1. And we're going to hit enter, and that's going to turn it on. So that's one way to turn the plot on. If I hit enter again, I turn it off. So it's off now. So back into stat, where you had all your info. Sorry, not into stats. Stat plots. Can anybody get to that screen? So those of you who have calculators, see if you can get to that screen where it says all those plots are off. Jenna and Zach and I think it was Megan. Can you guys get there? The one nice thing about Desmos is that it automatically draws the plot for you, whereas the calculator doesn't unless you tell the calculator you want a plot. So I got to that by going second and then the y equals button. You see where it says stat plot above that? So second and y equals gives me that screen. And then I'm just going to hit enter to go into plot 1. And notice the first toggle switch is on or off. So I'm going to turn it on. And then for the type, I'm going to leave it at that first highlighted choice right there. And then I'm going to make sure X list and Y lists, oops, this way, say list 1 and list 2. And I like the biggest mark because it's easiest to see. So I use the one on the left. Once I have that, I can just say quit. So I'm back on this screen. Now I could just graph this and try to set up a window by hand, but sometimes in these application problems, the numbers are kind of wonky and we end up all over the place where we've got, you know, maybe some really big numbers or maybe some really small numbers. So one thing that's helpful on this is to use Zoom data or Zoom stat, depending on the version of your calculator. We're going to hit the zoom button, which is top middle. And we're going to go all the way down toward the bottom. Let's see if I can remember the number. It is number 9. On my calculator, it is Zoom stat. So I'm going to go all the way down to number 9 and hit enter. And there, those got plotted for me on the screen with a window that fits the data pretty nicely. If you use trace now, you can jump around from point to point. You'll just trace along the points. So that's the plot itself. Then if you want to add that line to it that we had, remember we calculated the linear regression. You can either manually type that into your y equals, which is kind of a pain, or you can go into your y equals and you can type y equals ax plus b or whatever letters they used on your calculator. Even better than that, you can just dump it in. Let me show you this. So this is one of the other later steps on that handout. Let's see. Tell me, Jenna, you've got a newer calculator. Zach, is your calculator one of the newer ones? Okay, and then Megan, is your calculator a bit newer too?
Yeah, mine's a TI-84 plus C Silver Edition.
Okay, so you guys have a little bit easier way to do this than I do. But if you go into that stat where you and calc where you created the linear regression, you probably had to type information onto a screen when you did that, right? It looked different than what mine looked.
Yeah.
Yeah, so when you do that, notice there's a little spot that says store regression equation. Can you see that?
Yeah, I see that.
Okay, on that location, say Y1, and then it will automatically store the equation in Y1 for you. For me to do that, what I have to do is essentially do the calculation and then go back to Y1, and I'm going to have to tell it that I want that equation. So I have to go grab it. These instructions are on that sheet, but I don't think any of you need them because you guys all have newer calculators. But here's what I would have to do. Variables, and then statistics, and this is kind of a pain. This is why you're glad you have a newer one. And then I get that whole thing dumped in there with all of the decimal places. The nice thing about doing it that way is that I don't get any kind of round off error. I've got all of the data in there. And now when I hit graph, it graphs that line along with the points. And notice how much worse this one is. Those points don't look very close at all. And that kind of makes sense because back in Desmos, if I go back and peek over there, the R value was only about 0.8 and the R squared was like 0.66. So this wasn't nearly as good of a fit for the data. So what's going to happen for our project is that you're going to have a bunch of data, probably more than 5 points, quite a bit more, not too many, but you'll have significantly more than 5. I'd say around the double-digit number of points, 10 to 20 maybe. And then you're going to take that data and you're going to answer some questions about it. And I'll have you do some mathy things along the way that you'll have to do without the calculator, but then you'll do the linear regression and talk about some of the things like, what does the slope mean? You know, what does it mean if, you know, maybe it's data related to how quickly an infection is spreading. And what does it mean when we say that the number is going up by, you know, so many people per day or so many people per week or whatever our units happen to be. So what you'll need to do should be pretty clear there, and you can always ask questions if you need to. So does anybody have any calculator computing type questions? Did anybody come up with any other questions that they want to ask now that it's 1 o'clock and you're not still asleep? No, I'm just kidding. Any other troubles you guys want to ask about? Okay, I am not going to make other things up for you today, but what I will do is I will hang out in here. So I think I'll probably stop recording in a minute, but I'm going to hang out in here. If you guys just want to work on your homework and you run into questions, you can ask me questions. I will hang out in our Zoom meeting until 1:55 or until all of you leave, whichever comes first. So if everybody's gone, I'm not going to hang out. But if you want to sit around and work on your homework, I'll hang out in here too and keep my audio on so I can hear you if you come up with a question that you need to ask.
Just in case, could you possibly have the document in e-learning?
Yeah, I'm going
for
to
the
put it up
calculator?
there.
Gotcha.
I will, thank you for the reminder. I'm going to write that down right now so I don't forget to do that. Plus, that'll be nice for anybody who wasn't here. So that they can get that as well. So I made myself a note and I will do that as soon as I start uploading stuff after class. Any other questions? We all good? All right, you're welcome, Megan. Have a great day, everyone. And again, if you stick around, I will stick around and help you out with whatever you need help with.